Did you know your DTX cable analyzer can tell you whether you have water in your cabling system? In this real-world example, I'm going to walk you through that process and diagnostics. And not only am I going to confirm there's water in the cable, I'm going to actually tell you where that water is in the cabling system. So in this example here, we see that return loss failed with a margin of minus 7.7 dB. That's a very significant failure. Now, just as before, we need to check to see that return loss is only the failure and resistance is not the issue. And when we look at the resistance here, all four pairs are roughly the same. So that indicates that we don't have a DC contact resistance issue. If one of these pairs was higher than the other, then we have a contact resistance issue, but we don't. So I'm going to hit the exit key and go back down to return loss. And I'm going to hit the enter key. Now normally at this stage in the game I would be telling you to find out which is the worst performing pair. But when you look at this trace, there's something rather unique. And what I'm going to do is I'm going to zoom in. So I'm going to press the F2 key and the right arrow key and again. When you look at this trace, what you see is that all four pairs are following each other. They're almost identical. Now, they're failing at the lower frequencies, which as in the previous module indicates that we have a cable issue. But when they're failing exactly the same on top of each other, that tells me I have water in the cable. And at this stage in the game, there's no point in going on. That cable's got to come out. It's probably in conduit, and you've got to find out how to dry out that conduit. If it's external, then you'd be needing to look at an OSP cable. Let's take this one step further. I'm going to hit the exit key, and I'm going to go down to my feature called HD TDR Analyzer. This is a return loss failure, and so I should be able to look down the cable, see where the impedance mismatches are, and figure out where this water in the cable is. I'm going to hit the enter key. Then I'm going to hit the F3 key. And I'm going to hit it until I get to pair 3,6. I'm only doing that because that's the shortest pair. That'll give me the correct distance to the fault. Because when you're talking about measuring the outer sheath, that's done based on the shortest pair in the cable. Now, you'll notice that the cursor has gone to 60.7 meters and has shown an anomaly of minus 16.4. That is really bad news. I mean, just for the cable alone, we don't want more than minus 0.8%. So when we're seeing minus, 16.4%, something really dramatically is going on at that location. I'm going to hit the F2 key, press the right cursor key, and again, and up, and maybe up one more, just to give us a better picture of what's going on here. So what are we looking at here? We see this down spike, and then it comes back up, it goes along, and then we see a vertical spike, and it comes up and it goes down. When it goes down 16.4 and it comes back up, it hasn't technically recovered. What that is telling me is that my impedance changed by roughly 16.4%. So from this point on, it's definitely not 100 ohms. It's probably more like about 85 ohms. And then when it gets to almost the end of the link, we get a positive number and it comes back down again, and that returns us to roughly about 100 ohms. So here's what we can do. We'll take it off zoom mode. We'll move the cursor to where this starts. We'll set the marker, and then we'll move to where it ends. I would say roughly about there, indicating that we have about 6.7 meters of cable at the end of the link which has water in it. So let's just recap that. When you look at the return loss trace, if you see all four pairs following each other on the graph at the lower frequencies, you have water in the cable. When you look at the TDR, you're looking for significant events, and most of the time when you have water in the cable, a significant event is going to be anything over -5, -6, or +5 or +6%.